Hello friends, today we are going to learn about rational numbers class 8 mathematics. Let's get started. Suppose there were 5 friends. They went to a shop. They want to purchase a box consisting of 5 pens. The shopkeeper told that the cost of the box is rupees 22 and these 5 friends all together purchased 5 pens at the rate of 22 and they want to share individuals contribution. Contribution means what is the amount that each person has to give to the shopkeeper. Therefore, they should calculate 22 rupees into 5 parts. Therefore, each part is be equal to 22 by 5 rupees. And this 22 by 5 is a rational number. Now you can understand what is a rational number. A number which is in the form of P by Q, where P is an integer, Q is an integer. Therefore, 5 by 4 is an rational number, 3 by 4 rational number, 6 by 9 rational number, 10 by 5 rational number. Let us come to the definition of integers first. Integers comprises all the numbers from 0, 1, 2, 3 and so on to infinity. And coming to the negative side, -1, -2, -3 and so on to infinity. Therefore, it can be written in the form of set. What do you mean by a set? You can represent a number system by using brackets. It is -infinity. Here we are representing integer number system by the set -infinity, -3, -2, -1, 0, 1, 2, 3, infinity. This is the definition of integers. Now we will get the definition of whole numbers. In mathematics, we have to keep one thing in mind. If we want to define a number system, it is always good to use set theory. Therefore, we are using set whole numbers is equal to bracket open 0 comma 1 comma 2 comma 3 comma and so on to infinity. Infinity is a very larger number and it extends a very higher number which is unable to we cannot predict it because it is a number. Suppose you say the infinity number 99999 and there is one number in addition to this before number, therefore 0000001, therefore again 1 is there, again one number higher, therefore infinity is a higher number which is unpredictable. It is a positive number. In the negative side, it is a negative number, negative infinity. Coming to the definition of whole numbers, it will start with 0 and 1, 2, 3 and so on to infinity. Means it is a natural number including 0. Now what is the definition of natural number? One, two, three, so on to infinity. It means natural numbers plus number 0 is called as whole number. And then we will go to the rational number. We already told that a number which is in the form of p by q, and we told this number is what is this number? In the definition of rational number, we are considering the form p by q where p and q are integers. And you will definitely get a doubt, what will happen if q is equal to 0 and p is not equal to 0? It means any other number other than 0. Then the p by q format will give rise to, let us say p value is some 4, q value is 0. We know the format of any p by q is q will divide p, and this is the answer or quotient. This is called divider. Or divisor. Here what happens? 0 will be the divisor, and let us say 0 5 ja 0, 4, 0 1000 times is also 0, and again the answer 4. It means that there is no proper product for the number 0 to give the exact number or number nearer to 4, because any number multiplied by 0 will give rise to 0. Therefore, in the p by q format, q should not be 0. If q is 0, if q is equal to 0, the number is undefined. It is very important. It will be useful for higher classes even. Therefore, this q should not be 0 for a rational number to exist. Okay. After this, we are having so many examples of rational numbers. 3 by 2, 10 by 17, minus 3 by 2, minus 6 by 4, 10 by minus 9. These all numbers are rational numbers only. And in your textbook, you have given one observation for calculation of change in temperature per hour. The observation is change in temperature per hour. There were timings like that. Timings were given 10 o'clock, 12, 3 p.m., 7 p.m., 10 p.m. Let's say this one 12 noon, because it will cause some ambiguity. 12 noon. Temperatures were given like this: 11 degrees centigrade. You know the temperature will be measured in degrees centigrade and degrees Fahrenheit. General usage is degrees centigrade. Okay. Change in temperature per hour. The question is change in temperature per hour. Here how many hours are elapsed? 2 hours. For 2 hours, the change in temperature is 14 degrees centigrade to 11 degrees centigrade. What is 14 degrees centigrade? It is the latest at 12 noon. And what is the other one? The past temperature at 10 a.m. How much is the change in temperature? 3 degrees centigrade. For 2 hours, change in temperature is 3 degrees centigrade. For 1 hour, how much is that? 3 degrees centigrade by 2 hours. Always write in this equation format, and at the final answer making point you just make this number to come this side. Therefore answer is 3.2. Units are very important: degrees centigrade per hour. Keep in mind, for first 2 hours, that is 10 am to 12 noon, there are 2 hours. The time period gap is 2 hours, because after 10 11 am is there, then 12 noon, 2 hours. In the 2 hours the change is 3 degrees centigrade. For 2 hours it is 3 degrees centigrade. For 1 hour what you will do? You will just bring this number underneath, under this number. Therefore answer is 3 degrees by 2 hours, degrees centigrade by hour. In the same manner you will calculate 12 noon to 3 pm. Answer is 14 degrees centigrade to 17 degrees centigrade. Therefore difference is latest minus older timings by time gap, what you really observed before. 12 noon to 3 pm is 3 hours. And the difference is means 17 minus 14 is 17 is 14 divided by 3 hours. Therefore 3 by 3 is equal to 1 hour, 1 degrees centigrade per hour. This is also one rational number because it is 3 by 3 and both are integers. It means one is a whole number, one is a natural number, one is an integer, and one is also a rational number. Now we will get clear picture. This is one set. It is natural number set. This is another set. This is whole numbers, whole number set. In natural numbers it will start from 1 2 3 and so on, and its whole number, one number 0 will be adding to natural numbers. And this is the integers. After adding negative numbers, the integer numbers will come. And in this is rational number. This is the rational numbers. which will be having fractions p by q format where q is not equal to 0. See, natural numbers start with 1 2 3 and so on, and when we add 0 it will become whole number. When we will add negative numbers it will become integers, and when there are fractions they are the rational numbers. Therefore rational numbers is a combination of integers, whole numbers and natural numbers, and also there are some fraction numbers. Let's come and analyze rational numbers closely. For every number system, we are having some properties such as closure property. It means it is the name itself will indicate the property of closeness. Suppose we are having two integers 3 and 4. We want to know about the closure property. By examples we can get the definition also. Even adding up 3 plus 4, it is 7. What is the 7? Whole number. Means when we add two whole numbers, two integers or two natural numbers, we'll get the sum in that properties. Like if we add two whole numbers we will get one whole number. If we add two natural numbers we will get one natural number. If you add two integers we will get one integer. Therefore this property is called closure property under addition operation. Again, when we multiply two numbers, we'll get whole number. Means again we are getting a whole number. It can be defined for closure property under multiplication. Suppose we subtract two numbers, two whole numbers. The answer is -2, which is not a whole number. Therefore the closure property will not be satisfied in subtraction operation. Similarly, when we add two rational numbers, three by 4 plus 4 by 5. Okay, how to add these numbers? how to add these numbers. First of all, we have to take the LCM of the denominators. For 4 and for 5, the LCM is 4 into 5, 20, because there are no common factors. Therefore, the LCM is 20, and in the numerator we will get the number of this approximately of exactly opposite number, 3 into 5 plus 4 into 4. Therefore, answer is 15 plus 16 by plus 20, 31 by 20. How to calculate the sum of two rational numbers? We'll clearly observe. Again, we'll take the same example, 3 by 4 plus 4 by 5. The LCM is 20. Leave it here like this. See, what is this? 3 by 4 into 5 by 5. Because this number gets cancelled, both are 1. Therefore, the number will be remain itself. Just try to change the format. 3 by 4, 3 by 4 into 5 by 5 is equal to 15 by 20. This number, we turn this into 15 by 20, and we will turn this number into 4 by 5 into 4 by 4, because here the denominator is 20. We want to make this number denominator also 20, therefore 16 by 20. If both the denominators are same, we can add the numerators. Therefore, adding this is equal to 31 by 20. In this way we add. The subtraction also the same. Minus 1 by 20, because here 16 is higher number, we have to introduce this subtraction symbol. In this way we will get. And we will go to the properties of closure property. Closure property in 4 operations. Closure property in 4 properties, rational numbers. First, we will check addition, whether we get again the rational number when we add two rational numbers. Take an example. Let's say 2 by 7 comma 5 by 8 Let's add 2 by 7 plus 5 by 8. Both LCM is 56 because there are no common factors, and after cross multiplication 2 into 8 plus 5 into 7, therefore 16 plus 35 by 56, therefore 51 by 56. This is also a rational number. Means, what do you mean by this? Closure property holds good for addition in rational numbers. What do you mean by this? If we add two rational numbers, the result should be also the rational number. This is the property of closure property. Yes, we got the answer. The answer is also the rational number. Therefore, the answer is the rational number will satisfy the closure property. Next, subtraction. Let's find the difference between two rational numbers 5 by 9 and 3 by 4. Answer is 5 by 9 minus 3 by 4. We have to take LCM. 36 is LCM because there are no common factors, therefore we have to directly product them, means multiplication 9 and 4, and the denominator is 36 and the numerator is 5 into 4 minus 3 into 9 equal to 20 minus 27 by 36 equal to minus 7 by 36. Again we got the rational number. Therefore, this is the closure property was satisfied in subtraction of rational numbers. We have to know the sign conventions. This is the symbol for belongs to. This is a symbol. It will be inverted A. We can say that this is inverted A. This is reflected. Reflected means when you keep anything in alphabet, the alphabet will be in reverse direction, in the left to right. This is the sign for all. Let us say natural numbers. We know that natural numbers 1, 2, 3 and so on up to infinity. Belongs to means a number belongs to this complete set. We know that 4, take a number 4, belongs to the natural number set. Minus 5 belongs to integer set. 0 belongs to whole number set. We understood belongs means when we represent the symbol, the number to the left of the symbol should be in the whole set, means the complete set of the number set given towards rightwards. And for all, What is the usage of this symbol for all? We will be further notice the usage of for all. Let us say for all AB belongs to Q. Q is the representation of rational numbers. Keep this in mind. Q is a representation of rational number. For all AB belongs to Q means these numbers are like that. They are all rational numbers. Suppose 3 by 4, 6 by 9, like that. Anything may be happening for numbers AB. 2 by 3 minus 3000 by 156,293. We can have large numbers even. And let's go for the next closure property. In multiplication. Suppose we take two numbers 6 by 5 comma 6 by 5 comma 19 by 2, and we want to multiply 6 by 5 into 19 by 2. Therefore, the numbers are 19 by 6 into 4. The value of 19 is 54 and 5 into 2 10. Understood? Numerators will be multiplied and denominators will be multiplied. It's not like the math means addition and subtraction, where we have to take the denominator LCM and we have to make denominators equal like that. Here we directly multiply like this. Therefore, we again got this rational number. Therefore, we'll represent the closure property will be satisfied for all the numbers A, B belong to Q. Q is a rational number set. A into B also belongs to rational number. What do you understand by this sign convention? For all A and B, take two numbers like anything, any rational numbers, two rational numbers. How we can know that these two numbers are rational? By making them belonging to Q. This is belongs to, you know that. Therefore, AB belongs to Q means it's a rational number, then the product will be also the rational number. Let's come to the division property, closure property. In division, take two numbers again, 2 by 3, 7 by 8. when we divide 2 by 3 by 7 by 8, what we have to do, we will keep the numerator same and we have to invert upside down the denominator. Therefore answer is 16 by 21. This is also a rational number. Therefore closure property will be satisfied in division also. How we can represent for all a comma b belongs to rational number a divided by b will also belong to rational number. But keep in mind, any number is in the form of a by b, or let's say p by q. What we have earlier said, q should not be equal to 0, because otherwise the number will be undefined. If q equal to 0, the number will be undefined. Therefore 0 by 0 also undefined. This is the closure properties of rational numbers. Let's find a quick table of what are the closure properties exhibition by different number sets. Here we will write number sets. This is the closure property. In this addition, subtraction, multiplication, division. And numbers are natural numbers, whole numbers, integers, and rational numbers. Come on students, tell whether the additional property under closure property under addition will be applicable to natural numbers or no. Yes or no. Yes. If 3 plus 4 is equal to 7, 7 is also a natural number. And subtraction, no. Take example. Suppose 4 is a natural number, 4 is a natural number. 4 minus 4 equal to 0. Please observe here. If we have said that the addition property is applicable to natural number under closure property, then it should be applicable for each and every number of all the natural numbers. Then we will say that addition operation will be applicable under closure property in natural numbers. Otherwise there is even one case is there. Let's see in natural numbers. 4 minus 4 is 0. 4 minus 7, it is minus 3. It is again an integer. Therefore what we will say in integers, in natural numbers, the subtraction property was not satisfied under closure property, subtraction operation. In multiplication, yes. In division, it is again no. Why? 3 by 4. This is not a natural number, it is a rational number. Q denoted by Q. Whole numbers. Addition, yes. Subtraction, no. Multiplication, yes. Division, no. Integers. Addition, yes. Subtraction, yes. Multiplication, yes. Division, no. Rational numbers. Addition, yes. Subtraction, yes. Multiplication, yes. Division, yes.